Hello, I am Mr. Fixit from ES Repair. Many hard drives today use a technology called S.M.A.R.T, Self-Monitoring Analysis Reporting Technology. If you have not heard of S.M.A.R.T, it is not surprising. There's no standardization for the technology. Now you may have seen advertisements like this and they always mention smart monitoring. Now, it's primarily used in hard drives, solid-state drives, and embedded multimedia cards to monitor potential problems with the drive. The technology was designed to alert the user of pending drive failures so that the user can be able to back up their data before the drive fails. There are two classifications of drive failures. Predictive failures are determined by monitoring the performance of the drive. As the performance of the drive diminishes, the data can be used to predict when the drive will fail. Unexpected drive failures happen without warning. This can be from several problems ranging from electronic component failure to mechanical failures. Over half of the drive failures are due to some sort of mechanical failure. Some indications that a drive is failing are increased heat output, increased noise level, and problems reading and writing data. The first disk monitoring was developed by IBM in 1992. It was called the Predictive Failure Analysis, which monitored several key health parameters of the drive to determine if drive failure is imminent. PFA was first used in IBM's AS400 servers and was limited to only a binary result, pass or fail. If a problem was detected, the PFA would send a signal to the disk controller so the next time the PC boots up, the user can be warned. At the time, the PFA data was only accessible during the post in BIOS. There was no communication to the operating system. This was a problem because the user will never know if a problem exists until they restart the PC, and by then, the computer may not even reboot. In 1995, computer manufacturer Compaq, now HP, with disk manufacturers Seagate, Quantum, and Conner, united to develop IntelliSafe. This would monitor the drive's health parameters and send the data to the operating system and the user space monitoring software to provide real-time monitoring of the drive. When Compaq submitted IntelliSafe to the Small Form Factor Committee for standardization in 1995, the committee liked the approach of IntelliSafe because of its flexibility. It was supported by the development team, plus IBM and Western Digital, whom at the time didn't have any kind of failure prediction system. Now, each disk manufacturer was free to pick parameters they want to monitor and set their own thresholds. After its release to the public, it became known as S.M.A.R.T. The original version only monitored the drive's parameters as data was accessed or written, meaning the drive is online. It was later upgraded to add the ability to monitor the drive's parameters while the drive was idle or offline. The second upgrade added failure prevention measures by relocating data in bad sectors to reserved sectors. It's a process known as remapping that occurs while the drive is offline. Can S.M.A.R.T be beneficial? Well, the answer is yes and no. The data can be used to determine if the drive is failing. However, there is no industry-wide software or hardware standards for S.M.A.R.T. For instance, the data interchange. There are many ways to connect a hard drive to your PC, which makes it difficult to know if S.M.A.R.T data can be accessed correctly by the operating system. Some S.M.A.R.T enabled motherboards and related software may not be able to correctly communicate with the S.M.A.R.T firmware in the hard drive using certain interfaces. For example, many external hard drives using USB, Firewire, Thunderbolt, and eSATA cannot send S.M.A.R.T data to the PC. Even operating systems like Windows may not be able to see the S.M.A.R.T data on the hard drive if it is part of a RAID system. Some programs require an administrator account to query the hard drive's SMART data. The implementation of SMART is only in a handful of drive manufacturers, with only a few aspects being standardized to permit compatibility at the protocol level. For a drive to be legally called a SMART compatible drive, the manufacturer must monitor at least one parameter. There is also a wide range of interpretation of the SMART data that varies a great deal between the hard drive manufacturers. Every manufacturer has their own set of thresholds and parameters to monitor their drives. Although the technology was meant to warn the user of an imminent drive failure, there is no common ground between manufacturers and the user. Manufacturers use the SMART data to determine the cause of the failure to help build better drives. There are several apps you can download that can access the SMART data and display the results. A typical report will have the attribute ID as a decimal number or as a hexadecimal number, the name of the attribute, its current value, its worst value, its threshold value, and its raw value. The current value is the current state of the attribute. Higher values are usually better for some attributes, where a lower value is better for other attributes, such as temperature. Many manufacturers use a range of 0 to 100, where 100 is the best and 0 is the worst. However, some manufacturers use 0 to 255, so that 255 is the best, 0 is the worst, and 100 is nominal. The worst value represents the worst condition of the attribute at any point in time. There is no mechanism to reset the SMART attribute values, which makes sense as some SMART attributes for some manufacturers fluctuate over time, so that keeping the worst one ever can be meaningful. The threshold value is the attribute's limit before it is considered exceeding specifications. This will trigger a SMART alert, setting it from SMART test passed to SMART impending failure or a similar status. The raw value is data in hexadecimal format used to create the current value, but some attribute values on some drives cannot be reasonably interpreted, since there is no standard on how manufacturers use this raw data. This is a new solid-state drive that I had recently installed. As you can see, most of the values start at 100. During this video, you may have also noticed that most of the attributes say vendor specific, and most of the thresholds are at 0. That's because the developer of this application doesn't know all the specifications for this model. However, drive manufacturers like Western Digital, Seagate, and Samsung have their own smart diagnostic software you can download to check their drives. You could look up the ID number to find the attribute, but that doesn't mean that is what the manufacturer is tracking. For example, look at ID 244 or F4. This is normally used to track the number of logical block addresses that have been read from the drive during its life cycle. It's often used in conjunction with 242 or F2, but this drive uses the attribute to monitor the thermal throttle status, which tracks the rate at which the drive was forced to slow down due to high temperatures. The SMART data can be confusing since there is no direct way to interpret the information. All the information is derived from the raw data, and that varies between manufacturers. Nonetheless, it can provide clues if the drive is having problems. The most important attributes to watch are the power on hours, which tracks the total count of hours the drive is in the power on state. This value is shown in raw data as a hexadecimal number. You can convert the hexadecimal number into a decimal to get the actual value. However, some manufacturers use minutes or seconds. The life expectancy of a hard drive in perfect condition running 24 hours a day, 7 days a week is 5 years, or 43,800 hours. The temperature shows the drive's temperature in degrees Celsius. The ideal operating temperature for hard drives is between 25 degrees Celsius and 40 degrees Celsius. Although hard drives can operate between 41 degrees Celsius and 50 degrees Celsius, active cooling is highly recommended. The read error rate tracks the rate at which an error occurs while reading data from the disk surface or a memory block on solid state drives. The attributes raw data varies among manufacturers and has no meaningful information as a decimal number, but the lower the value, the better. Spin-up time refers to the hard drives that track the average milliseconds it took the spindle to go from 0 RPM to full operational speed. Some manufacturers have a preset value, so if the spin-up time takes longer than the preset value, this attribute will begin to change. The spin-up retry count also is for hard drives. This tracks the number of times it took the spindle to get up to operational speed after the first attempt failed. Any change in this attribute indicates a problem in the mechanical subsystem. The current pending sector count. This tracks the number of sectors that are waiting to be remapped due to read errors. When a drive detects a bad sector, the sector is flagged for remapping. Drives will not remap the bad sector at first sign of trouble because the data is not known, but it may be able to read the sector later and then remap it. However, some drives may try to write data to the bad sector, and if this process is successful, the drive removes the bad sector from its pending reallocation list. But if such a drive contains marginal sectors that consistently fail only after some time has passed following a successful write operation, then the drive will never remap these problem sectors. The reallocated sectors count tracks the number of bad sectors that have been found and remapped. This value is primarily used as a metric of the life expectancy of the drive. A drive with significant reallocations at all is more likely to fail in the immediate months. The uncorrectable sector count tracks the number of sectors that have failed remap operations. A significant increase in the raw value denotes the drive is having problems. Solid-state drives use the program fail attribute, which do vary by manufacturer. This tracks the number of program operations that failed since the drive was deployed. You may also see the erase fail account, which tracks the number of erase operations that failed since the drive was deployed. Media wear out indicator monitors the level of wear on the flash memory and solid-state drives. The higher the current value or lower the raw value, the better. Some applications like this one shows a percentage of the wear level. Since flash memory have a limited number of writes, this will indicate when the drive is near the end of its life cycle. Some drives use available reserved space to track the amount of space that is reserved for remaps. It's often seen as a percentage, and most thresholds are set to 4%. Some drives have a threshold exceeds condition, or TEC. It provides an estimated date the drive is expected to fail. It is determined by the S.M.A.R.T firmware by tracking the rate at which the critical attributes change. The date is no guarantee because the drive can fail long before the date or after the date. Many S.M.A.R.T enabled motherboards have built-in S.M.A.R.T self-test for testing the drive in the event the PC will not boot. PC and hard drive manufacturers often have their own software in either part of their diagnostic tools in the operating system, or it's an app that you can download. The short test is a quick check of the electrical and mechanical performance, as well as the read performance of the disk. Electrical test might include a test of the buffer RAM, a read-write circuitry test, or a test of the read-write head elements. The mechanical test includes seeking data tracks by testing the servo. It can scan small parts of the drive surface, and the area is vendor specific. Plus, there is also a time limit on this test. It also checks the list of pending sectors that may have read errors. The test usually takes about 2 minutes, The long, extended test is a more in-depth check of all the components in the drive. This test can take as little as 10 minutes to a few hours depending on the drive. As you can see, S.M.A.R.T can be beneficial to help determine if a drive is showing signs of failure. But at the same time, the data can be confusing without knowing the true meaning of the data. Keep in mind that many drives do fail without warning. So if you ever get a S.M.A.R.T alert, you should take it very seriously and take the necessary actions to save your data. Well, this concludes this video. I hope it was very informative to help you better understand what S.M.A.R.T and how it can benefit yourself. Well, I'm your host, Mr. Fixit. Thank you for watching.